When industrial valves reach 42 inches, or DN 1000, and above, standard procurement rules completely stop working. At this scale, you are dealing with immense physical weight and fluid volumes that require an entirely different engineering approach. Selecting the wrong unit for a high-capacity pipeline leads to specific, catastrophic outcomes. A mismatched pressure rating results in devastating system blowouts. Poor dimensional planning leaves multi-ton assets stalled on flatbed trucks, and relying on standard designs causes lifecycle maintenance costs to explode. To mitigate these risks, we are going to build a custom procurement spec sheet. Step by step, we will define exactly what you need to safely vet and source heavy-duty international builds, specifically from manufacturers in China. In large-scale infrastructure, simply scaling up a small standard valve guarantees failure. Rigorous custom engineering tailored to your exact site conditions is the only way to protect a project of this magnitude. Step 1 is matching the internal physical design of the valve to the specific fluid dynamics of your sector. We start by looking at what the pipeline actually moves, like clear municipal water. For standard water transmission, you have two primary choices. Gate valves provide reliable, straight-through isolation. However, as sizes increase into the multi-meter range, butterfly valves are often selected instead to save critical weight and reduce infrastructure load. This animation compares internal geometries. Left, a wedge gate seals against clear water. Right, for harsh wastewater, a knife gate slices downward through dense slurry. For high-pressure oil and gas, standard wedges fail. Parallel gates expand to lock against seats, guaranteeing absolute shutoff. Regardless of the primary flow control, all large infrastructure sectors universally require check valves. These must be precisely sized to protect critical pump stations from the devastating impact of backflow surges. Selecting the wrong internal geometry for your fluid leads directly to rapid mechanical breakdown. Therefore, defining the valve type is the foundational data point on your custom spec sheet. Now that we have our internal geometry, Step 2 addresses the body. Expanding a valve's diameter radically increases the mechanical stress placed on the housing, forcing a strict reevaluation of base materials. The standard, cost-effective baseline is cast or ductile iron. This material performs exceptionally well, but its safe application is limited to standard municipal water grids. When you move into oil, gas, and industrial high-pressure networks, iron is insufficient. Carbon steel becomes the mandatory upgrade to handle the required tensile strength. This matrix plots fluid corrosivity against system pressure. For aggressive media like seawater, you must utilize stainless steel and duplex alloys in the upper right zones. But notice the red failure zone. Applying small valve pressure ratings to custom 42-inch builds causes catastrophic vessel rupture. Specifying the precise material grade based on customized, large-scale pressure calculations is the only proven way to prevent a structural blowout in the field. Step 3 requires solving the physics of operation. Extreme water weight and high pressure drops require massive torque. Manual hand wheels are obsolete here. You must specify heavy-duty gear, electric, or hydraulic actuators. Actuation is heavily influenced by the constraints of the installation site itself. Tight infrastructure hubs and subterranean pipelines often completely lack vertical clearance. This introduces a critical design choice for large gate valves, whether to specify a rising stem or a non-rising stem configuration. This split-screen schematic shows the difference. Rising stems offer clear visual confirmation, but as seen on the left, become disastrous liabilities in low-clearance environments. On the right, the non-rising stem operates safely within the cramped constraints of a subterranean vault. If you ignore the physics of actuator torque in stem clearance, you will procure a $1 million asset that physically cannot be installed or turned on. Step 4 shifts our focus from design to logistics and long-term planning. Purchasing the cheapest upfront option is a massive financial risk because the hidden costs of transporting and removing a failed 50-ton valve later will ruin a maintenance budget. You must specify inline maintainability. By demanding robust internal linings and accessible exterior lubrication points, you ensure the valve never has to be pulled out of the pipeline for routine service. With the technical design locked in, the final step is applying a rigorous vetting framework to international suppliers, specifically when sourcing from China. First, demand proof of advanced custom engineering. Do not accept a quote unless the manufacturer provides verified FEA, finite element analysis, simulation for your specific dimensions. Second, demand physical proof of extreme-scale testing capacity. Many standard factories simply lack the physical rigs required to pressure test 42-inch units before shipping. Third, require the manufacturer to prove their competence in logistics. They must demonstrate a track record of navigating international transport routing, managing complex lifting requirements, and providing field assembly support. Combining a rigorously engineered spec sheet with a heavily vetted manufacturer takes international sourcing from a dangerous gamble and turns it into a highly secure, cost-effective infrastructure investment. We now have our completed tool. We've matched the internal geometry to the fluid type, selected pressure-rated materials, calculated actuator torque, planned for spatial constraints, and established strict vendor testing criteria. Applying this exact framework is the dividing line between a successful high-capacity pipeline project and a logistical disaster. When you are ready to source, Valverno is a trusted large-diameter valve manufacturer in China. They possess the advanced engineering, the large-scale testing rigs, and the logistical expertise to exceed every point on this vetting checklist. Download the companion technical PDF guide below to finalize your parameters and submit your completed spec sheet to Valverno for a secure custom quote. Because in the world of large-diameter infrastructure, precision engineering on paper is your ultimate defense against failure in the field.